just wanted to brush like what has we discussed in the last class. We started the concept with skewness, and we have seen what is if there is some kind of asymmetry in the data. So that is usually called as skewness, and we have seen some definitions, and we have seen what is positive skew, what is negative skew also in the last class. So later we have seen how to identify the skewness in the data with the help of quartiles, and if there is any difference between, so this left side things is called as so all this will be considered as left skew data, because maximum of the data is present in this category and very few points are there here. Okay, and in between, if you're trying to find out the difference between Q0 and Q1, and if you try to compare Q3 and Q4, so definitely this will be a greater when compared to this one. So similarly, right skew also will be almost same. So if you see this one, so here it is less data, here it is some more data. So later we have seen some calculations like how the skewness is being calculated and plotted. So this is how the skewness data will be identified, and we have seen practical application of that also. I have just taken a data of some time spent by the customers in a restaurant. So a restaurant owner suppose if a restaurant owner wanted to identify is mean time or median time or mode of time is different, with that, for that skewness will give you a very good idea. And if you see here, mean waiting time of people is 7.6 and 67, and median is 7.6 and mode is 7.4. So this shows that the data is right skewed. Okay, so even you can compare here. So the first point is here, and if you just try to compare this to this side, there is some kind of extended tail here. So this is considered as a right tail. And we have already seen how that Excel will be calculating that one. So this is sample skewness, and this is population skewness. Okay, and later we have seen an example which is completely related to left skew data. If you observe this particular curve, so this is what the right side ending, and if I try to join to the left side, you can see some kind of extended tail towards left side of the data. And in this case, you see mean will be less than median and mode. So this is the indication of left skewness. And if you use the formula for that, you will be getting minus 0.58, minus 0.5 skewness of sample and skewness of population. So, and we have also discussed something called as moments of the data. So that is the deviations associated with the data, and we have got 4 types of moments: first moment, second moment, third moment, and fourth moment. Okay, and first moment usually deals with the difference of that particular observation and mean of the data. Okay, and if you try to square that one, if you try to square the difference, then it is called as variance, which is we usually call as second moment. And if you try to cube that one, so this gives you skewness, because we are reading skewness, and there are 4 methods which we have discussed to how to find out that skewness. Pearson has given one formula, Kelly has given one formula, Bowley has given one formula, Pearson, Bowley together have given one formula, but all will be either satisfying positive or negative, but there might be slight changes in the final values. But all these measures will give you the third, this cube of the differences between 1 point and mean. Okay, and if you try to make it power 4, so then we call that concept as kurtosis. Okay, and this is for completely for ungrouped data, and this is for grouped data. So this is what we have seen in the last class, and we have seen like there are 3 types of kurtosis. So 3 categories of kurtosis, and the first one we have seen it as leptokurtic, where peak will be more when compared to normal curve. And I believe everyone remember that normal curve. So this is what simply a normal curve. If there is more peak associated, so then it is called as leptokurtic. And if there is no peak, then that is called as mesokurtic, which is quite a normal curve. And platykurtic is something which is very less peak. And if you see in this curve, so if you have a curve like this, okay, so this is going to be platykurtic. If it is normal, then it is called as mesokurtic. If it is a peaked one, then you call it as leptokurtic. And we have seen some problems related to that leptokurtic also. So probably by tomorrow afternoon, I'll be sharing this document along with that assignment number 2. So ideally, I should have shared assignment today itself. But assignment 1, I think I've got only one submission. So that's why probably I'll be sharing that by assignment by tomorrow. Okay. So you can see this one, there is huge peak which shows leptokurtic, and the second one is platykurtic, which is somewhat very small. Okay, so this is what we have discussed in the last class, right? So now we'll see something called as, until now we have seen, which is completely about a single variable. Okay, so is everyone okay with this? Because as we have already seen this, I've completed a bit fast. Now we have to start a new topic, which is correlation, regression, and mean differences, so which comes in parametric statistics. Is that fine? Is that fine? Or like last class, only one student was there, like one person was there. So I think she'll be able to understand perfectly. And if at all, if the others also, if you watch videos, definitely, I feel you will be able to understand that. Okay. So now we are going to see correlation. So what do you mean by correlation? Again, this is not test to any test anyone's knowledge, but I just want to know how far you're comfortable with that terminology. That's what. What do you mean by correlation?
So it could be how two variables or factors relate. If there's a relationship between them, positive, negative, or neutral.
Okay. So what might be the business application of learning correlation?
I think in marketing, price to quality, or if something new gets introduced,
Okay.
how it correlation.
Nice, nice. So one is one application in marketing. So if you try to see how these two variables are related, if you normally there is a tendency among the people that if you spend more price, there will be more quality. So this is what usual expectation of the people. So in marketing, and as you have mentioned, price and quality, so these two will have some kind of positive relation according to the people. Okay, that is perception, right? Any other?
Sir,
Yeah.
also like in psychology
Mm.
or in any other subject, basically the relation, it tells us the relationship between two variables, that what is the relationship, if one is increasing or decreasing, then how the other one is also increasing or decreasing or not. Like in marketing, we say the relationship between demand and supply, so how these two are correlated. Or if in psychology we talk about, suppose the IQ and academic achievement, so how these two are correlated. This basically two variables, the relationship, what is the nature of the relationship between the two variables. So,
Fine. Very nice. Very nice. So as you have mentioned about IQ and the percentage of marks or the grade that people are getting, more the IQ, obviously the percentage will be more. So these two are also positively correlated, right? Any other example by any other professor? Because there are two more people. If even if they can share their opinion on the correlation, like where this correlation is applied in business or in other aspect.
Sir, in business, suppose like a new product is being brought about, sir.
Mhm.
So whether it will be the purpose of bringing that new thing is that it should replace the old thing. That is what makes it a best option. So in that, the people study how the consumer behavior would be towards these things. So they study what would be the relationship of the consumer relating to the product, and how much it is related that they will leave the old product and try to join with the new product.
Very nice. So all the three have given very good example, practical examples. Okay. And correlation simply deals with the degree of relationship between two or more variables. If you just see, there are basically three different types of categories of data. Okay. So what do you mean by cross-sectional data? What do you mean by time series data? What do you mean by panel data? So I'm giving three things. One is cross-sectional data. The second one is time series data. The third one is time series data. And the third one is panel data. So you have given very nice examples. I just want example from you regarding these three also. Panel data. Yes, now your turn. What is a cross-sectional data? Because here I'm talking about two or more variables. In that way, definitely we have to know what is what variable, cross-section means what, time series means what, panel means what, something.
Sir, is this about the like the time, like cross section means at one point in time? We are
Okay.
measuring the two variables, and time series would mean that at different points, like for example, we measured the variables in January and then we measured it in February, and likewise, like on the basis of time, we are collecting data on two different time. Is this what you are
Yeah,
asking, or is this something?
you're right. Then what is panel data?
Panels, or I'm not sure. Is this the combination of two?
Yeah, very
So
nice.
Okay.
Yeah. Any
actually,
other
I'm
answer?
also not sure, but I'm giving a guess.
Mhm.
Sir, like panel discussions are giving same question and asking the opinion of everybody.
Okay.
So is it something like that, that in this data also we try to collect same thing would be there, but we will ask many people? Is it something like that?
Yeah, I think the cross section and time series, when it is grouped together, like we are taking cross section means that many variables at one point of in time we are taking the cross section, and then same cross sections we are taking at multiple
Multiple
times.
intervals.
Yeah,
Oh,
yeah.
nice, nice. So when you have started the course, like in which month you have started this course? I think it is a 6 months course, right? When you have
August,
In
started.
I
August.
think.
August.
August.
August. Okay, so August. So in August, we have 5 students. So 5 students. One is Swati, second one is Varsha, third one Nimrat ma'am, Anjali, and some person. Okay. So what is the percentage of attendance or marks of Swati? Assume it is 70%, because I have seen one data like this. So Varsha, assume it is 80%. And Nimrat ma'am, it is 65%. So Anjali ma'am, it is some 76%. And some last person, assume it is 84. Okay. So here you are trying to find out different data points values in a particular time period. Okay. So this is example for a cross-sectional data. Okay. You're trying to find out values for different people. Either you can call it as percentage of attendance, you can call it as percentage of marks, or you can call how much is how many orders that you have made, something like that. Okay. And coming to the second one, time series data. So in August is the performance of these people are like this. Maybe if you take it as percentage of attendance or marks. So in September, assume it is 60, it has become 65. it has become 82, it has become 63. The fourth person has got 70, fifth person has got 50. Okay, I'm just taking a simple number, so don't assume these are marks or percentage for you. So now if you just see the first person, Swati's attendance in 2 months, or even if you can take it October, so this has become 76, there is some improvement. So here it is some 80, there is some decrease. So this has become 73, something like that. Now, if you see one person's data, if you're trying to find out at different time intervals, so 70, 65, 73, something like that, then that is time series data. Panel data is if you combine the total all variables data in different time intervals. If you combine these two, you will get panel data. So this becomes 78, this becomes 66 something. Okay, so this is what the variables data point something. Is that clear? Cross-sectional data means at one particular moment, you're trying to find out different people's opinion or different stock prices or different things. If you try to identify one particular data point or one particular person's percentage of marks or the score that they have got or attendance percentage of only one individual person in different time slots, then that is time series data. If you combine these 2 points, then you'll get panel data, because you are going to see something like different persons at different time intervals. Okay, it gives a clear picture. So now you can see, is there any increase or decrease over a period of time? So what is the correlation or the relation of marks of either Swati or Varsha or Nimrat or Anjali or some other person? So if you try to identify what is happening to this particular person's performance over a period of time, you are comparing two variables. Okay, so one is time, the second one is the percentage of marks or something. So under such circumstance, you will use this correlation. Okay, it tells the degree of relationship between two or more variables. If you see, since many of you, almost all of you are teachers, there is something called as demand. So and demand function or something. So demand will be determined or changed because of many reasons. The price will impact the demand, population will impact the demand, and the consumer tastes and preferences will impact the demand. Future price expectations will impact the demand. So now you see the demand, it will be affected positively or negatively when there is a change in price of the product, when there is a change in income of the consumer, when there is a change in future expectations of price, or when there is a change in population. So like that, if you try to identify how this particular component will be impacted with respect to this particular thing, so then that is called as a correlation. Is that clear?
Sir, I have got one question, sir.
Yeah.
Cross-sectional data gives you a clear picture. Yes. Time series we require when we want to see how they are doing over time period.
Yes.
Yes. Then what is the requirement of combining both two in panel data? What is the purpose of collecting a panel data then?
In time series analysis, usually you'll be taking only one variable and you will see how it is increasing or decreasing. But for a comparison purpose, definitely you have to see second element, third element, fourth element, fifth element, something. Okay, so for that purpose, you need to combine both rows and columns. Okay.
So in panel discussion also, whatever people I have covered in cross-sectional data, same people will be approached over different times. Is it that?
Yes.
Then how is it different from longitudinal study?
Longitudinal study is the other name given for panel data.
Okay.
Fine. So fine. Good. I got some doubts. Okay, so and the first time this.
Sir, 1 second, sir. I actually wrote that down as a time series. I thought was longitudinal. I thought because I mean I was looking at one example of production, that if production of E1, E2, E3 we are seeing, different employees.
Mhm.
Then across you're seeing that, how different people are doing in, then a production over of the same employees over the quarter 1, 2, 3, 4
Mm.
can be something like a time series.
Okay.
And panel will be overall production. How did they do? How did the entire company fare in, measured in terms of um, the first quarter to the fourth quarter? Then that becomes a comparison, how the company has done. So I thought that way, but that's not,
That's
that
what,
won't
like,
be panel.
yeah. So because time series analysis usually deals with only one variable and how that variable is changed in last 4 quarters. If you take one person, like if you take one employee, so Q1, his productivity is 50 products. Q2, his productivity is 60 products. Q3, his productivity is, assume, 72 products. Q4, his productivity is some 76 products. We cannot simply take a decision that employee is doing very excellent, because if you take the second employee, the employee 2 might have done here 40, might have given here 50, might have given here 60, might have become 80. You can make a comparison when you have the other data point or the other variable. So for that purpose, usually time series data deals with either only employee 1 or employee 2 or employee 3, something like that. If you want to make a comparison, definitely you have to compare with the other person only. Here, definitely the person is increasing. But if you see the rate at which the other persons are growing, definitely this person is not doing very great. For such things, you need panel data.
Sir, one more
Yeah.
question, sir.
Yeah.
Like what Madam Ma'am Nimrat ma'am said, time series could be considered as a longitudinal study. Suppose if we are studying, like in psychology, if we are studying only one person, or maybe in medical field, we are studying one person, a case study we are doing. Okay.
Okay.
So now case study, if we are doing and we are taking it for, let us say, over the lifespan we are studying it,
Okay.
then it will come under time series. Yes.
Yes.
And then suppose we are doing a cohort study over a period of time, say
Okay.
lifespan,
Okay.
then we will not consider it as time series, then we'll consider it as panel data. Am I right?
Yes, because you're trying to identify different peoples in different time spans. So it will be a panel data.
Yes, sir.
Right. Fine. Because many of the people will use different terminology synonymously. Okay. If I'm not, I don't exactly remember whether we have had any discussion on a multinational company and a global company like that, whether we had any discussion in any of the classes.
In two of the classes which I have attended, sir, no.
No. Is it Varsha?
Yes, sir. Yes,
So
sir.
I think Varsha has attended some higher number of classes when compared to other. Fine. So in that case, now I've got one more question. Like, as it is very good that I'm getting a lot of doubts and some sort of clarifications. What is a multinational company? Because today many people are actively participating. Let me ask a question. Yeah. So what is a multinational company?
So when it has presence in multiple countries,
Then it is a multinational company. Very nice. Then what is a global company?
So global would be, it has a presence, but it is headquartered. How would you say? The products are sold globally, perhaps, but it could be owned by a country.
Okay.
I don't know. I'm not sure.
What is an international company? What is a transnational company? What is a domestic company? So these are the 5 categories of companies, but most of the people will use left, right, up, down according to their convenience. But there is a differentiation among these 5. this is not to test anyone or not to undermine anyone, but I just want, like, many of the people, as some people will tell time series data and longitudinal data are same, both are the same, but so there is a difference. So like that, what is a domestic company? What is an international company? What is a multinational company? What is a global company? What is a transnational company? Whatever order which I have mentioned, first stage of any company is a domestic company. If the level of that company increases, then it becomes an international company. If the level of that company increases, then it becomes a multinational company. If the level of operations increases, then it will become a global company. If the level of that company increases, then it will become a transnational company. So this is the transition of any company from domestic to the next level. Now, can you just tell, like, what are these companies' deals? What is a domestic company?
So domestic company is what is originating in one place. Means like if I'm starting something, it is the domestic company which I'll be starting here in this place, approaching in this population only.
Okay. Suppose, assume I'm not good at drawing, but assume this is as India. Okay, so assume this is India, and if your company has, if there is a company's presence within India and throughout India, so then that is called as a domestic company. We have got a number of examples for that. Fine. If the level of operations increases, I have mentioned it becomes an international company. What is that international company?
Suppose if it is reaching to nearby population around India.
Okay. Sri Lanka, Nepal, Burma, Pakistan, China, something. Suppose the demand for that company, suppose this domestic company, demand for that company is 100 units. For getting some economies of scale, they have produced 130 products. Okay, but they are sure that they'll be able to sell only 100 products within India. Then what do they do with the remaining 30 products, excess 30 products?
Sir, international would mean that they are like established in this country only, Indian only, but the product or the remaining 30 they are maybe exporting or exporting internationally, something like that.
Yeah, they will export. Like, where do they export? Can they export to United States of America?
India.
Can they export to United States of America or France or Germany or United Kingdom, because they are very hard, stronger currencies than India? Can they export to these places?
No.
Why?
Sir, this is because, see, these companies are already well established and their production and their consumption of the products are well settled within themselves. They don't require other people to support them. So this domestic company will approach those countries which is lower than, means in a position where they are not able to meet their own demands. There they will go and search for their market.
Okay, so
Then
can
only
they
they will get.
can they sell that product in South Africa, Sudan?
If the demand is there, then. If not, then they cannot approach.
Okay, very nice, very nice. Anyone, because there are some more
They
people.
can create a demand. And
They
if
can
you know, it
create a
depends on the value of your rupee versus a dollar or a pound or a dirham or whatever.
Okay. But the simple problem here for the company is they have produced excess and they cannot afford transportation cost to neither US or France or Germany or UK or Sudan or South Africa. They will be simply dumping the excess production in the nearby country to get rid of the production. That's what. So that is an international company. Okay, an international company is one which tries to export because they have produced excess and they don't care whether Pakistan is expecting that sort of product or Nepal is expecting that product, that sort of product, China is expecting that sort of product, or Sri Lanka is expecting that sort of product. They try to export because they don't have any other option and they have to get rid of the production. Okay, so the product might be successful in the other country or failure in the other country. They cannot do anything. They are helpless. So that is an international company. So a company exporting the products without concerning the other country to get rid of the production, excess production. So that is an international company, right? Coming to the multinational company. So they also export the product and services, but they try to create the production according to the requirements of the second country in which they want to step in. Suppose if any domestic company wants to sell some product and services in Sri Lanka, they try to create, like one person has told, you can create a demand in that particular place. They will identify the requirements of the people in Sri Lanka, then they try to produce a product and export that one. Similarly, they try to identify a product like which is required in China, produce that and send it to that place. What is required in United States of America, you can send it that one. All business process outsourcing are multinational companies only because they are catering to the requirements of the other country. Is that clear? That is the
Yes,
difference
sir.
between
Yes, sir.
international company and multinational company. In international company, since I have produced more, I am sending to the nearest country to get rid of the production. But in multinational company, US shift, UK shift, because you are working in UK shift to cater to the needs of UK people. You are working in Germany shift to cater to the requirements of Germany people. That's why there is a separate time. There is a moonlight saving. Lot of things will happen. Next comes to global company. So as I told, if you multinational company, we have got suppose Microsoft. Who is CEO for Microsoft? CEO of Microsoft? No CEO for a Microsoft company. Okay, so Microsoft is from which country? Guys, am I audible or not? Hello?
Hello, sir. Yes,
Yeah,
sorry, sir.
yeah. Maybe
Yeah, sir.
I am audible or not, because
Yes, sir. You are audible. So
fine.
Microsoft is an American company, right?
Yeah, US company.
US company.
Yeah, so Microsoft US CEO will be one. Microsoft India might have assumed Microsoft India will have one CEO. Microsoft UK might have one CEO. So a CEO will be there in different countries, and all the CEOs will be reporting to home country like US. So US CEO will be the higher authority, and other countries people CEO also will be there. So they will be reporting to that person, but decision can be taken in that country also. That is a global company. They will have branches in other places, and CEOs will be operating in that country up to certain extent. Okay, so there will be a lot of power to take decisions, and ultimately the ultimate authority is going to be the home country CEO. But other countries also, they will be having CEOs. Is that clear? That is a global company, right? Last is transnational company. So for them, total globe is a small village. They'll hire people from one country. They'll take raw material from one country. They will take machinery from one country. They'll purchase some other aspects, packing material from one country, and they sell in the other country. Okay. So that is a transnational company because they feel total world is a small village or someplace. So this is what the 5 stages of any company. Is that clear, people?
Yes, sir. So
But
Microsoft is an example of global company.
It is transnational company, but most of the people feel it is a global company. But it
Because
is,
most of the people, actually, I did not know this earlier, and we usually say these companies are MNCs.
yes, exactly. So that's what
Yeah.
the thing that we have, like, there is no problem in that, but there is a big difference, like heliocentric theory and
Yeah, yeah,
geocentric
yeah.
theory. So
Understood.
that's the thing. So I spent some time to tell about this only, because maximum people feel data is about data. That's what panel data, all data is something related. But there is a minor difference when you go in depth. Okay, so now coming to the R correlation thing. And for correlation, there are different assumptions. The first assumption is linearity, second assumption is normality, third assumption is homoscedasticity, the fourth assumption is no outliers. The fifth assumption is the last one, this one, independence. If you take linearity, as we have mentioned, that correlation is degree of relation between two or more variables, all variables will have a linear relation. So usually they assume some kind of this thing, okay? And there will not be any quadratic relationship, something like that. So that is what basic assumption of correlation. Is that clear? The first assumption is if you take x-axis and y-axis, definitely these two are linearly related, or there will be linear movement between these two variables. So that is the first assumption. And the second assumption is both the variables will follow a normality principle. Okay, so it will have this sort of things, a normal curve. So this is the second assumption. We can try to fetch or fit some kind of relation for abnormal or not normal things also, but most of the times it is believed that both the variables which are in for which we are trying to find out correlation will follow normality principle, right? Since we have already seen normality, I'm just going to the next one. Homoscedasticity. It deals with the variance of the variables. Okay, so variance of the variables are same or similar. Okay, so that is the third assumption of correlation. There is a thing which is called as heteroscedasticity, which is quite opposite to this one, which tells that as we are trying to find out the relation between two variables, both variables will have different variances. So that is heteroscedasticity. Homoscedasticity means variance will be somewhat similar. Is that clear? As we have already calculated variance also, I believe you are quite okay with this. Is that
Yes,
fine?
sir. Yes, sir.
Next one is outliers. Usually correlation variables will not be considering outlier data. If there is an outlier, definitely your data will be skewed and will not be able to get the perfect values. So outliers will not be existing in the correlation. So this is what one assumption. Suppose if you find any correlated variable, we will be trying to clean the data by making it as an average or by removing that variable. If it is completely not if it completely becomes an outlier. So outliers should not be there in correlation. And next thing is independence. As if you remember, which I have taken one example, like a demand is one thing which is influenced by price of the goods and the income of the consumer, population, future expectation of price, taste and preferences of consumer, something like that. All the variables are independent to each other. So every variable will have its own strategy or it will take its own moments. So this is the other correlation assumption. Okay, so these are the 5 assumptions of correlation. Is that fine, people? Can I just go to the next one? Okay, so now as we have seen what is correlation and what are the assumptions of correlation, now we have to see how it is measured. Usually correlation will be measured with interval scale and ratio scale. I believe I remember one person has clearly explained what is nominal data, what is ordinal data, what is interval data, and what is ratio data. So since we have already seen that one, I'm feeling, I assume that you are quite okay with this measurement of interval scale and ratio scale, and we'll see what are the types of correlation. So the types of correlations are positive correlation, negative correlation, and no correlation. As there is no relation between two variables, I have mentioned that in the first point itself. And if you see a positive correlation, if you observe increase in the temperature, obviously the demand for just cool drinks, either will it increase or decrease?
Increase. It will increase.
It will increase. And similarly, if there is a decrease in temperature, what will happen to the demand of cool drinks? Suppose it becomes a winter or a rainy
It will
season,
Decrease.
it will decrease. So when in summer, temperature will increase, cool drinks sales also will increase. In winter, temperature will decrease, sales also tentatively it might decrease. So this is called as a positive correlation. And coming to the negative correlation, if you give any discount, price will come down, which will increase the sales or demand. So these two are inversely proportional or negatively correlated. Clear? And if you increase the price, law of demand tells that your demand will come down. Price increase will decrease the demand, and similarly, if you decrease the price, your demand will increase. So this is called as law of demand. Okay. I hope you know this thing, right? There is an interesting fact about law of demand. Is there anyone who teach business economics or managerial economics, something among you? No one? Fine. So in that case, we'll leave that. Okay, so this is what the positive correlation, negative correlation, and no correlation. If you take the temperature as well as stock market, probably they will not have any relation. So that is called as no relation case, as there is no relation between the two variables, right? And correlation coefficient. So Pearson has given, like many people have given correlation coefficients, and most of the people feel Pearson correlation is somewhat widely accepted or widely used. So while measuring that one, and one more important concept is the correlation coefficient values range between -1 and 1. Okay, so it might be perfectly positive correlation, perfectly negative correlation, so partially positive correlation, partially negative correlation, or zero correlation, something like that. So there are different types of things, but all these correlations will range between -1 and +1. Okay, and if your correlation ranges between -1 and 0, then this is called as a negative correlation. For negative correlation, curve will be like this. Okay, and if R is 0, then we call it as no correlation. So this is what some no correlation, because we don't know when it will come, when it will increase, and there is no relation. So if you take a points, definitely we'll have a lot of scattering will be there. So that is what no correlation position. And if correlation range between 0 and 1, then that is called as a positive correlation. So this is what example of the curve for a positive correlation, right? And how this will be calculated? So positive, the correlation will be calculated with the help of formula. Correlation coefficient is equal to covariance divided by standard deviation of X and standard deviation of Y. Okay, so there are basically two types of variables which will be used. One is dependent and one is independent. Between X and Y, which is dependent, which is independent? X and Y, which is dependent variable, which is independent variable?
Is this a trick question?
Yeah, it's a question.
No trick question.
Sir, but
A simple
Dependent.
question.
sir,
No,
Yeah.
I'm saying, sir, this is a trick question.
No, not a trick question. It's a straight question, simple one.
No, I'm saying like, sorry, Varsha ma'am was saying something.
no, it's okay. Complete it, then I'll tell.
Yeah, both are independent, right? Both should be independent for correlation, right? talked about. So no, I don't think
Yes, sir,
dependent and
because in
independent.
experimental research only we use independent and dependent variable. In correlation, it should be independent.
Very nice, very nice. So you're observing in depth. Okay, so that's what. Fine. If it is a normal straight line, y is equal to mx plus c. In this, if it is a normal straight line, equation of a straight line, y is equal to mx plus c. In this, what is dependent variable? What are the variables here? Y, x, m, c, something.
So this is the regression
Yeah, regression line. Normal straight line equation, regression.
yes, so y is dependent and x is independent.
Y is dependent variable, x is independent variable. What about m and c?
M
So
are numbers. They are numbers.
this is
Coefficient.
regression coefficient and c is the constant.
Oh,
Not
can you name
We
this?
don't.
Like it's a
This is
number.
forgot.
regression.
Yeah, it is just a number. Fine. Is there any name given to that m?
Yes, it is regression.
Coefficient.
Yes, coefficient. That part
Or
of
the
y.
slope, yes.
Slope. Yes, slope.
It is the
Not
slope.
slope. It is intercept. Intercept.
This is
C
the intercept. C is the
is intercept. So y is equal to mx plus c. Nice, good conversation. So m is slope. Like, what is the slope of that equation? Right. So fine. So now we'll see a coefficient correlation. So good. Today the class is very interactive and people are answering and people are raising many questions and asking. Very nice. So correlation, see here below are the details of rainfall observed and yield of the paddy. So ideally, according to the assumption of that correlation, these two are independent. Okay. So definitely no one can control in this one, and yield of the paddy is related to something. So straight away I cannot tell that this is dependent, something like that. But though these two are independent, now we are trying to find out, is there any relationship between these two existing? Maybe it is positive, negative, no, something like that. And find out the correlation and compute the correlation and correlation coefficient between rainfall and paddy yield. So these are the data given in centimeters. These are the data given for rain as well as paddy yield. So first observation, 113 centimeters. In that time, the yield is around 18,000 some tons, something like that. In second year, maybe you can call it as a time series data. 102, we have got 15,000 tons. Third, 95 is the centimeters and 13,000. 120, 19,000. So 130. So these are the details given for the correlation. Now we have to find out the correlation. And correlation coefficient, the formula is given as covariance divided by standard deviation of x into standard deviation of y. For time being, you can tell that since this is completely natural, we call it as x variable, and yield of the paddy somewhat dependent on this one, we call it as y variable. Okay, is that clear? It's not I'm telling completely these two are independent,
Yes,
these two are independent, but for time being, I'm taking that one. Now we'll see correlation coefficient calculation, right? So now the first thing which I hope you can see my Excel, right?
Yes, sir. Yes.
Okay, the first thing which we want to do to check whether that correlation is there or not is we have to see the scatter plot of these two variables. Okay, if I just see these two variables, since it is somewhat a bigger thing, I've taken a combo chart for that. Otherwise, I should have taken that a scatter chart. But if I take scatter chart, since the one variable is in 113, 3-digit variables, and second variable is 6-digit, we'll be getting a value like this, and we'll not be able to see how this is moving. So what I did is I've just taken a combo chart for that. Okay, so now I have got some better value because I've taken a secondary y axis also. So this has given me a curve like this. Okay, now if you see the first, if you take only the blue values here, so this is what the rainfall observed, like 113, it has initially come down, it has increased, and something like that. If you take only the right values, if you take only the paddy yield, it also got decreased up to a certain extent. So then it increased as your rainfall is increasing. But suddenly in the sixth observation, rainfall is very high, but at that time it was not able to give very good yield. Maybe some other influences are there. So it has come down and later it has increased. But it shows some kind of linear movement. So this is what I want to tell, because we have to check all the assumptions, linear assumption. And once I'll share this sheet with you, you can test for the normality, as we have seen that in the third class. So normality assumption, you can check for the outliers. By seeing this data, definitely you might not feel that there is an outlier, because the total range is somewhat manageable. Even in this case, thousands, the data is manageable. Like this has satisfied all the aspects of the correlation thing. It is independent and there is no outlier. Normal thing is there, and the first one is linearity is also there. If you want to see that correlation thing, 1 minute. So I'll just take the formula for this. This is the formula for that. So I'm just taking the formula here. Now I hope you can see the formula here, right? Just mention formula here. I copied and pasted here. So the covariance divided by standard deviation of X and standard deviation of Y. I believe that you have already come across how to calculate standard deviation, variance. So I'm not spending that time. We have to find out covariance. So covariance is simply the difference between these two variables. Okay, if you see, I'm taking the covariance value also here. Okay, so covariance is somewhat here. It is X minus X bar into Y minus Y bar divided by N. So I'm assuming it as population. That's why I'm not using N minus 1. So X minus X bar, Y minus Y bar divided by N. So if you see that one, X minus X bar is the average value. Okay, suppose I'll just take this to a new one. Okay, now I have to find out this thing. So I have to use these two to find out my correlation here. Okay, so first step I have to find out is the mean. So sum of these values is equal to sum from here to here. Okay, and similarly for this also I have to find out sum. So next I have to find out mean or average. It is already I found out sum divided by how many variables are there. So what is the total number of variables given? So I've got the mean value also here. For the same thing, I'm using for the second variable also. And standard deviation. So for time being, I'm assuming it as population standard deviation. So I'm using std dot p, all these values. And I believe you have already seen how to do this, and I think I've given some assignment also on this. Okay, so this is what my basic data. So whatever the data is given, for that I've calculated average, I calculated, and a standard deviation also I've calculated. Okay, so this is for population. So standard deviation for population, right? Now I have to find out X minus X bar. That should be multiplied by Y minus Y bar. So I'm just using X minus X bar, X minus X bar. So X bar is, so X minus X bar. So my mean is here. Since I have to make comparison with all the variables, I'm just making that one. So this is minus 4.86, something like that. Similarly, I have to find out Y minus Y bar. Okay, so Y value is this one, Y1, Y2, Y3, Y4, Y5. I'm just finding the deviation, the moment one, first moment, that's what. Okay, so minus mean of that particular value, and I've fixed that one. I hope you are following, right? I'm not going fast because I feel definitely you have come across all these things. Is that fine?
Yes, sir.
Product of deviations is equal to, so X minus X bar multiplied by Y minus Y bar. Okay, so whatever the values which are here, I'll be using this one. Okay, For finding my covariance, I found x minus x bar into y minus y bar, but I have to, since there is a sigma here, I have to find out the summation of that one. Okay, so if I just use that summation, this is what my 50% of covariance is done, because only I have used summation value. So now if I just want to find out the average of that one or divided by that one, so this divided by count of these values. So first 1, 2, 3, 4, 5, 6, 7 values. So this is what my covariance. So covariance is here. If I want to find out correlation, so correlation coefficient is equal to my covariance divided by product of this and this. Okay, if I just close that one, the correlation is 0.084 something. We can check whether we have correctly done or not. So correlation with Excel output. So if you just see, if you just type a function called as correl, you will be able to get that correlation. So you have to take an array of observations. So the first array will be rainfall array, comma, the second array is going to be this thing. If you try to use that, you have got some value. Okay, so if you try to match to match the decimal points, we should be getting same as this one. So this and this should be same. Is that clear?
Yes, sir.
So this
Yes,
is
sir.
what.
Sir, I have one question. Sir,
Yeah.
how do you copy this word data and paste it on Excel sheet?
Okay, so the formula which I have created here. Okay, for
No,
that,
not formula, sir. This data which is in the Word document. I want to put it into the Excel for calculation. How will I take it?
so so this I have already had my Excel file. That's thing only.
Okay.
Suppose if you want to copy some content here, Windows
Yeah.
Shift and S. If you use
Okay.
that, it will allow you to take whatever the data. Since I've copied this data, I can paste anywhere I want. So this data has come here. So this is the shortcut key. That's what, nothing more than that. And Excel, I already copied this one and use this here. Okay.
Yes, sir.
Fine. Okay, so this is what my correlation, covariance, and this is the thing. And there are some more problems that we'll see in the next class. Is that clear? Is that fine?
Yes, sir. Yes, sir.
Fine. Okay. So thank you for your patient listen. Sir, thank you, sir. I'm done for today. Is Sir there or not? Okay, so probably Sir is not here. Okay, ma'am. It's like so. Thank you, and I'll be sharing this Excel sheets by tomorrow to you so that you can practice from your end. Okay, and so thank you. Good night. If anyone has got any doubts, you can ask me. I'll be okay to give any answers for doubts. If not, we can close the session for today.
Sir, I just wanted to ask which book can we refer for all these? Like I have studied general things, but like what you are telling is really in depth, like the assumptions and all, which I have not come across. Can you suggest some stats book or something which is really good?
Yeah, definitely. There are multiple books, and definitely I'll suggest 2 to 3 books so
Okay.
that you'll be able to get everything. And
Okay.
Sir has written some book. I'm following 50% from that only.
Oh, okay.
Okay.
Okay, sir.
Okay. So thank you, ma'am. Okay.
Thank you.
Thank you. Good night. Ma'am, Farah ma'am, is that fine?
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir.
Okay. Thank you. Good night, ma'am. Bye.
Good
Good night,
night.
sir. Yeah.
Good night, students. Sir, are you there? It's SPSS time, sir.
Hello.
Yes, sir. Sir, it is SPSS time.
Yeah. Mona Lisa has joined.
Yes, sir. She has attended the this applied psychometric class also, sir, today.
Okay.
Good evening, Mona Lisa.
Good evening, sir.
Acha, whether you have done your reporting?
Sir, I am writing.
Okay.
Meanwhile, I went to my home. Then this week I will do.
Okay.
Yes. I came today, so I am very much tired today. So I will start work, sir.
Okay. Okay. Okay.
Yes, sir.
I have done research on your 215 data,
Yes, sir.
and it appears to me that it is a better fit.
Yes, sir.
So that is the advantage of your data.
Yes, sir.
Now my interest is to publish the paper in some journal.
Yes,
And
sir.
for that reason,
Hmm.
some literature review and other things are important. Method part and other things.
Method. Yes.
Because I have tested only the measurement model
Hmm.
of the questionnaire.
Measurement model. Yes, sir. Yes, sir.
By using confirmatory factor analysis.
Yes, sir. That we can show in my work, sir.
Yeah, because this is not related to your PhD.
Yes, sir.
In your PhD, you can show confirmatory factor or structural equation model.
Yes, sir. For my PhD, I may use the Amos software, sir.
Yeah, you can use the Amos software.
Yes, sir.
From where you get Amos?
Sir, I have Amos installed with me because I had attended one workshop from GM University Sambalpur, sir.
Okay.
Yes, sir. I did my MPhil there, GM University Sambalpur. Yes.
Okay, okay.
Yes, sir. I have installed and I learned something about Amos. So I have to sit with some expert and I will do that.
Okay.
Yes, sir.
Then you can apply the whatever I have received through the Art Studio. You
Yes,
can
sir.
apply the same model.
Same model.
That is the confirmatory factor analysis model through
Yes, sir.
Amos.
Yes. Using Amos?
Yeah.
Yes, sir. Yes, sir. Sir, my PhD also I require some help to write introduction and literature review, sir.
Oh, sure.
Yes, sir. What point I need to cover and all? I need some help, sir.
Okay.
With job, it is very hectic nowadays to complete PhD and all. True fact, I am saying, sir. With job, it is very tough, sir.
Yeah, this is a common issue.
Yes, sir.
Every student who is doing PhD during the job,
Yes, sir.
same problem is there.
Yes, sir.
Dr. Shima has joined.
Yes, sir.
Shima has similar problem.
Yes, sir. Because you know, sir, nowadays all the college having NAC visit, NAC work and all. We are having the extra work for NAC also.
Yeah, for your neck.
Yes, sir. Yes, sir. Daily some seminar, conference, and
You have
daily
to do many
program is
things.
going. Yes, sir. Um,
You can collaborate with RPRIT.
yes, sir. Yes, sir. You
That
can.
would be better.
Yes, sir.
If you can collaborate with RPRIT, particularly on environmental issue, I think
Yes,
that is better.
sir. That I will share with my director, sir.
Sure.
Yes, sir. He is Dr. C.V. Gopinath. He is from Hijack.
Okay.
Yes, sir.
Hello, Shima. How are you?
Good evening, sir.
Good evening, Shima.
Sir, I'm good.
Do you want to show something?
Sir, not yet. Because I didn't do anything. Sir, one thing I want to ask, like there was a one outlier in previous analysis. I removed that.
Yes,
Then
that is okay. And
then
you have to mention.
okay. Then initially when I am discussing about the sample, should I include that case or not?
No, two things are there. In the method section, when you are discussing the participants, there you can include this individual. But during the result section, okay, there you will not include that individual.
Okay, जैसे I prepared pie diagram for data visualization, like the percentage of my demographic variable. So in that case, I need to include that case or not?
Yeah, definitely. There you can include.
Okay. But not in the statistical analysis. Like in correlation and one-way ANOVA, I have to exclude that case.
No. Sorry. When you tell that is data were collected from, then you can include that individual. And after that, you can tell that is okay, I examined the outlier and I find that is one individual was identified as the outlier. So that individual is not in in my model.
Okay. Means from pie diagram, I have to exclude that particular case. Okay.
That means your final model is based upon
92
the
samples.
number of cases without outlier.
Okay.
Hello, Poonam. Good evening. Poonam, how are you?
Good evening, sir. Sir, I'm okay. Working
Okay,
on my
thank
data,
you.
sir.
So Poonam, will you share something, your report
Sir,
or data or something?
give me just 5 minutes. I'll share my data with you.
I think you have finished the data analysis part.
Sir, there were certain outliers that were creating certain problems in the data. My standard deviation of when I was calculating p-value of the group, comparing means, there was higher standard deviation in my data. Hello.
Okay, so you have to mention that is, I have noted the outliers. So those outliers are not in the final model.
Okay, sir.
So initially they will be, but after outlier they will be removed.
So I have to remove those outliers, no? Okay. So I have collected some more data. I'm just working on that only.
Oh, very, very good, very good. Because your topic is very good, altruism and happiness.
Yes, sir.
It's a very good paper. And have
Thank
you
you,
finished the literature review part, etc.? Introduction and literature review.
Sir, I have formulated introduction, but my word range is exceeded. So I have to summarize that. And I'm working on my review of related literature. I have collected some review related to altruism and happiness, but directly linked researches are still, I'm working on that.
Okay.
I have got few studies directly related to my variables.
Because you have the three things. First paragraph will be altruism, second paragraph happiness, third paragraph altruism and happiness.
Okay, sir. In the introduction part, no, sir?
In the introduction part.
Okay, sir.
Three things will be there.
Okay, sir.
And the literature review also covered, that is the prior studies on these issues.
Okay, sir.
And the research gap.
Sir.
You can write down the research gap also.
Okay, sir.
Farah, any other student will join?
Sir, sir, I informed everyone. So, sir, I think they will join, sir. So, you can start the class, sir.
Okay. So, dear students, your aim is to examine the descriptive statistics. It covers mainly the central tendency, variability, and the correlation statistics. Okay. And if you want to add something more, you can add it. But we will consider only your descriptive statistics. So when you write your result, at that time, your first paragraph will be on central tendency. Second paragraph will be the variability. Third paragraph will be any sort of correlation. For example, item total correlation and what it represents. So, Poonam, in your case, first will be the table on descriptive statistics of altruism. Second table on happiness. And the third table will be the correlation between altruism and happiness.
Okay, sir.
So third table will be interpreted also in your result section.
Okay, sir.
And when you write the result section, then you have to define the statistics, particularly what is descriptive statistics and what do you mean by the central tendency. And after that, you can relate that in this study, I have noted the mean such and such, and this suggests what.
Okay, sir.
Similarly, in case of the variability, you have to write down what is called the variability. And in this case, I am considering the standard deviation, skewness, and kurtosis. So this table and the figure, they indicate the standard deviation is lower than 1. That means within group variability is less. And if it is higher than 1, that means within group variability is high. But not very high, because the standard deviation is less than the mean. Okay.
Ji, sir. Ji.
That you can write. After that, the altruism and happiness correlation with the graph.
Okay, sir.
In the last class, I taught how to plot the correlation graph, particularly the regression line. Based upon the data of Shima.
Ji, sir.
And if you have the SPSS data, then I can tell you that is in this way you can do the analysis.
Ji, sir.
Do you have the SPSS data?
Yes, sir. I have. Yes, sir. I have SPSS and I have the data right now. Let me connect with
So
my
you
laptop.
can share so that I can guide you properly.
Yes, sir. So I'm just connecting it with my laptop. So it will take 5 minutes.
Okay. Okay, Poonam, now you go to the variable view. Okay.
Yes, sir.
What is your age total? Okay,
So
I
this
got
is my
it.
H total. Yes.
So now you click the graphs.
Drafts.
Then legacy dialog.
Yes, sir.
Then you click the scatter plot.
Scatter.
Click it.
Yes, sir.
Then simple scatter. Then define. Then you click A total in the x-axis. And H total in y-axis. Now you click options. Okay. Then continue.
Okay, sir.
Then okay. Now you click the graph.
Again, sir, graph?
Yeah, inside the graph, you click it. No, whatever the graph you have now. Yeah, this
Yes,
is the
sir.
scatter chart. Yeah. You click it.
Okay, sir. Anywhere on any data?
No, you just click. No, click is not proper. There will
Sir,
be
where I
another.
have to click? Where I have to click, sir? Anywhere?
Okay, you try again. That thing not coming. Yeah. Now it comes.
Yes, sir.
Now you go up. Just above
On
the
charts.
180, there is one icon. You go up.
Here, sir?
Right side. No. Go, yeah, below.
On.
Below.
Yes.
Yeah. You click it.
Okay, sir.
Okay. So that is your regression line.
Okay, sir.
If you collect more data,
Yes, sir.
then possibly you will get a better line.
Okay, sir.
Because your R square is 0.02. So
Yes, sir.
2% variance it accounted.
Okay. Sir, should I close it?
Yeah, now you can click the file in this chart. Here is in this chart, you will click the file. No, in the chart.
In the chart.
No. What is your regression line? You have shown the regression line just now.
Yes, sir.
Okay, you click it again.
In the graphs.
In the graph, click it again. No, it will not come.
Okay, sir.
Okay, you do again. I think that is, yes.
Sir, I
Yeah,
have,
yeah.
yes.
Now you got it.
Yes, sir.
Okay. Now in this chart, there is one file edit view option. It is written. Yeah,
Yes, sir.
click it.
Yes, sir. Here it is. Okay, sir.
There you write down save chart template.
Okay, sir.
Okay, then cancel. Again, you go to the file, close, click it. Yeah, now you get it.
Okay.
So this will be shown in your report.
Okay, sir.
And now you click analyze, compare means, independent sample t-test. Then you click the shakes as grouping variable. Define groups 1 and 2. Continue. And you click the test variable A1 total, A total, and H total. H total. Then okay. Now you get, Acha, there is no significant difference.
Yes, sir.
That you can mention, that is, I do not find any significant difference. That means
Okay,
male and female, the altruism level and the happiness level is same.
Okay, sir.
So you can use the grand mean. Okay. So you click analyze. Descriptive statistics. Descriptives. Then H total or A total. A total, H total. Okay. Okay, so this is your mean. Oh, H total
Yes,
is same problem.
Yes, sir. When I'll
H
copy paste it
total
on Excel,
calculation
it will
is
show the.
problem.
Yes, sir.
H total mean should not be this thing.
Yes, sir. So when I copy paste it on Excel file, then data is like, okay. Here it is showing error.
Okay, you go to the H total. You show me your data, not analyze.
Yes. Yes, sir.
You go to the variable view.
Variable
H
view,
total.
this is my H total.
You just click 52.
So
52, click it.
yes, sir.
What is H total?
This is it. So this is my H total, this data.
Achha, H total includes what?
So this
How
is the
many
total
items
score
are
on
there?
happiness. 29 items are there, sir.
Oh, is it 6-point scale?
Yes, sir.
Okay. So whether this data in your Excel?
Yes, sir, I have data in my Excel.
So please share your Excel.
Just a minute.
You go to the H total. Okay, and go below. Okay, after one, you go to the 62, BE62. You click it, BE62. Click it. Equal to B sum. Oh, sum to হবে না, sorry. You write down oh, understand now. Okay, you write down average. Bracket BE2 BE2 colon BE61. Bracket close. Enter. Yes, this is your average value.
Okay,
120.97.
So that is the same value.
Whether the same value is there? 120.97 in SPSS output.
Sir,
yes, sir.
I think that it is the same
120.97.
value.
Yes, sir, it is the same value.
Okay.
So it also
It
happen
is
in my
showing
data.
So shall I share my SPSS file?
You share.
Yes, sir. Just a minute. So
So
here it is showing
120.97.
1.20. Yes, sir.
Then how do you interpret?
So here I have to interpret the difference between the two groups. No?
Then how do you interpret?
Okay, sir. I'll interpret the happiness score. I have to interpret.
So
So
because
they are
one,
showing good, more than average happiness. 120 means more than average happiness.
now how many items are there?
29 items are there, sir.
29.
Sir, in this scale, total score is divided by
So
29. And then
yeah,
whatever the result we get, we have to interpret that. The average
you have
score
to
we have get here.
divide this value with 29. Then
Yes,
you
sir,
can find out.
120.9. Yes, sir. The range is between 4 to 5, and this indicates rather happiness. Matlab, a pretty good happiness is present in the young adults. That I have to interpret.
Okay. Otherwise, you can do another thing. That is,
Yes, sir.
instead of the total, you can consider only the average one. I think that if you follow, that gives you better impression.
Okay.
You go to the Excel.
Yes, sir.
This you go to top.
Yes.
Yeah. Now after the BE, what is BF? There you write down H mean. You write down H mean.
So
after BE, BF will be there. Yeah.
Yes, sir.
You go to the top, the header.
Yes, sir.
No, it is 23 row. Go to the first row. Yeah, there you write down H mean. Then you go to the BF2 equal to
Yes, sir.
average. Bracket. Now you select H1. Where is your H1? H9, 1 sec. Yeah, this is your H1. No, you click the 6. 6,
H6,
AB2.
Yes, sir. Okay.
And then you select this particular row. 6 to 1, 1. You go to the last one. Except total. Not the total. Up to BD2. Yeah. Bracket. Enter. Now you drag it. No. You have to select 3.58. 3.58. This is okay. Enter. Now you select 3.58 and copy. Paste. No, you go to this. Now you copy this one, this data. Just copy. Control C. And you go to the
Yes, sir.
SPSS.
Yes, sir. Just a minute, sir.
Yeah, after the total, okay.
So I'll change this variable name afterward. This is the data I have copy pasted in.
So you can take one column, the blank column, and there you paste it.
Here. I have pasted here, sir.
Oh, this is, acha, you have paste.
Yes, sir.
Okay. Now you can apply this one. Analyze.
So I have to change this variable's name.
Yes. Your average will be 4.12.
My average. Yes.
Yes. Now you click analyze. Descriptive statistics. Descriptives. Then you click this variable. Yeah.
So I have to remove this.
Yes, remove them.
Cancel. Analyze.
Not the cancel, reset.
Yes, sir, I'm just resetting it.
Then you select only this one.
Yes, sir.
Now, okay. Okay, now it becomes
So
more
now
meaningful.
4.19. Yes, sir.
Yeah,
4.19.
so it is more than
4.19.
That means the happiness level high.
Yes, sir.
Same thing. If you divide it by 29, you will get maybe the same thing.
Yes, sir.
But this is more meaningful.
Yes, sir.
Now, if you do the You go to the analyze. Compared means independent sample t-test. Instead of the shakes, you take education.
Education. So I have changed my data just to copy paste it.
You go below.
So where?
No. In your window. After A10, after H total.
Yes, sir. Is it visible, sir?
Now, where is your region, education?
So just now during pasting that mean, I have removed that.
Oh, achha.
Yes, sir.
Okay, you can check at. Yeah?
I'll do that, sir.
Yeah. So I think now it is clear to you.
Yes, sir.
Same thing, because if you write down the sum, then the more characters are there. Therefore, it indicates E. And in this way, you will get better information.
Yes, sir.
You can do the same thing for A total also.
Yes, sir. I'll do that, sir.
Yeah. That will give you the meaning.
Yes, sir.
Okay. Thank you. Thank you, everybody.
Thank you, sir.
So I'm closing. I
Thank
think
you,
there is
sir.
no question at all. Okay. So, Poonam, please you write down the report now.
Yes, sir. Yes, sir. I'll do that, sir.
If you have any problem, please you contact me. I will help you.
Yes, sir. Thank you so much, sir.
Okay. Good night.